All right, got it. So good day, everybody. I'm just reminding you that the course outline gives you the things that we should be covering every week, and there are assignments for those who come in late. Just reminding you, it's a coursework only course. Concept note, literature review, and annotated bibliography, literature review, a bridge ethics report, practical assignments, and a theory test. All of them together worth 100%. The theory test will be given during lecture time in week 13, right? All right, so I'm going to go to the slideshow. Okay, so we're going to talk about writing data analysis reports and methodological approaches in computing. So when you write a report about data, just like in many reports for academia, you have an introduction, a body, and a conclusion. Usually you don't title the body. Same thing as this review. This review also has an introduction, body, and conclusion. The body is never so titled, it's just the conceptual name, right? So depending on the nature of the project, you either have conclusions or discussions or both. So it could actually be an introduction, body, discussion, then conclusion, depending on the, so usually qualitative projects could have discussions, and quantitative discussions could have what is called analysis, and then that leads to a conclusion. It sort of depends. And then sometimes there are appendices or one appendix. Right. So generally speaking, there are a number of things when you write about data. Remember, data is not just numbers, it can also be non-numeric, like interview, like the verbatim transcript of an interview is also data. So when you write a report, it should be well organized. It should have good visuals that are clear, attractive, and focus on the purpose of the report. And unlike when you write a literature review, which should have actually remarkable writing, for data analysis, it's really unremarkable writing. Usually data analysis is not exciting. It's trying to be clear and to the point, usually in a precise, concise manner. So, and so data analysis is really for people to understand what you find from data. Whereas when you write, whether for the newspaper, when you write a literature review, the idea is to have your writing be not only clear, but also to be interesting enough that people continue to read it. That's not the primary goal of a data analysis report. So what would you mean by being organized? Any particular audience that has access to the report should be able to find the topics. So if it's long enough, it needs to have a table of contents. Whether it has a table of contents or not, it should be in a way that people can find the detail that they need easily. In terms of visuals, whether it's tables, figures, or anything else like a pie chart, etc., they should all be clear, attractive, focus, and having essential points without being clear. So the idea is that the data that you show visually must be easy to understand. Shouldn't have too many colors. It should be something that people can't understand, essentially. So what we mean by unremarkable writing, I already said this earlier, it is so that the people understand the content. It's not about your writing. So you don't want to have be too formal, you don't want to be flowery, you don't want to be overly casual, you don't want to be overly brief or overly long, right? So you obviously don't want to have any grammar or spelling errors. And this you only know from experience and getting feedback, but you neither want the analysis to be too broad or narrow, because there should be some goal of a specific data analysis report. And if it's too broad, then people are like, so what's the point of this? And if it's too narrow, you may not answer, as in if you have the data that can answer a specific question, it should be answered through your writing. And generally, what is happening is you're not only giving the conclusion. I said earlier, there's a conclusion. Before you get to the conclusion, you need to have a body. So in that body, you're going to be basically talking about the process, not just the conclusion. So the data analysis report has the process. Right. So you have several different audiences typically for a data analysis report. There's a primary audience, which could be a client if you're being paid to do it, which could be employer. So the client could be your employer or somebody's paying you to do a report. It could be that you're doing it for research and then you and your other researcher. But there are other secondary audiences. So a lot of data analysis is for busy executives, and it should be that they can look at the data analysis report and get what they want quickly. And then there are other secondary audiences. Notice how it says the tutor is a technical secondary audience or technical supervisor. Why is it secondary? Because even when we give you to write a report in school, technically, we are not really the audience. We're asking you to practice for an audience that would be for like major project where you're making a report, which is to a panel. It's not to this set of people. You practice so that you can write for a journal. You practice so that you can write in a context where you're working as a job and there's some data and as you write it up. So the tutor is not the ideal audience because the tutor has different goals. Yeah. So when you write a report, you must think about some ethical issues. So one of the ethical issues, well, clearly you must not give false data, that's obvious. But in addition to that, you need to think about how you present the data so it doesn't mislead people, whether intentionally or unintentionally. So for example, if your sample size is small, you must actually indicate that, right? Maybe we'll give you some rules of thumbs. So for survey, sample size rule of thumb is that it's 100 or more. For a qualitative project, it's typically 30 or more. For a experimental project, it's 15 per group. So like in the simplest type of experimental study, you have a control group and an experimental group. So that'd be 15 times 2, 30. But if there was 2 experimental groups and 1 control group, that'd be 45 people. The sample will be 45 minimum. If your project is less than those rules of thumbs, you should always be talking about the number while you're writing about it. So let's say you did an interview of 10 people. You shouldn't just say 50% of the one that said. You would need to say half of the 10 persons or just 5 out of 10. So certainly if there are only 4 people, 2 out of 4. So 50%. Sounds impressive, however, it is misleading because if you only interviewed 4 people, let's say there were 10 people in the organization, 4 out of 10 is still not necessarily representative. So you need to put things that's going to be representative of your actual data sample. When you look at your research questions, remember, this is some of the things you want to think about. It should be feasible, so there should be an adequate number of subjects in your study. You should have adequate technical experience or be able to source it. It should be affordable in terms of time, money, and any other resources, could be your energy as well. And the scope should be able to be done in the time that you have. It should be interesting to somebody. If it's not interesting, then it's not the best research. It should be novel. So novel that it either confirming a previous study, refute, or extend previous finding. If so, maybe it's not a good best research project. It should always be ethical. And so all countries have ethics committees, usually housed in universities. Let's just take Jamaica. Jamaica will have ethics committee both at all the 3 major universities, maybe others too, but I know for sure. NCU, UTech, and UWI have research ethics committee. The government of Jamaica also has at least 2. The Ministry of Health and Wellness has a research ethics committee, and the Ministry of Justice has one for research on prisoners. So we have at least 5 research ethics committee. And if you do research in Jamaica, you should put in your proposal or ethics application to a research ethics committee before you start the study. And this study should also be relevant to the scientific community, and as in, remember they have this idea called significance. So the significance of the study is that it will either add knowledge, it will help with policy making, or help with future research. You know, something should be of value. Right. So, anybody has any questions or comments on what we've talked about so far? If not, that was just quick. We're going to move on to important issues related to research and computing. Now, the first thing before we move on to here, I hope by now you know, but if you don't know, I'm going to tell you that research is research is research. And what I mean by that, we're talking about academic research. So remember, in everyday language, you use the word research to mean any kind of investigation. What we're talking about academic research, we're talking about a structured, systematic way to answer a question that experts don't have the answer to. So when we're talking about that, no matter what the discipline, they're pretty much similar principles. What happens though is that methods can be different in different disciplines, but in both social sciences, humanities, and natural sciences, you have a similar structure. There are going to be research questions. There is going to be a review of the scholarly literature. There's going to be a set of methods that is going to be proposed to answer the research questions. The scientists are going to decide, the scientists slash researchers are going to decide how they're going to collect the data, whether primary or secondary, or both. And then you're going to analyze that data using, you know, known rigorous techniques in order to come to a conclusion. So despite that, so we already know that already. What in the world, before we're going to today talk about two things. So I'm going to first talk about how we set up major projects, so you know in advance. And then we're going to talk about some of the methods in computing, just so that in case you don't know, we're going to just talk about that quickly. So in our major project in SCIT, we have research only and research and development projects. Most of the projects are research and development, meaning that as part of the major project, you actually create what is called an artifact, which could be a software program. You know, it could be a prototype, but there are actually other kinds. It depends on your project. So we actually have different grading systems. I'm not presenting, I actually happen to be the major project coordinator, so I'm not giving the major project coordinator presentation, just giving you a preprint of what's going to be in your future if you are in the BSc computing program. I actually know that there's some students here in network and security and animation, and this exact thing wouldn't apply to you, but they just still get an introduction. So this is how a lot of research is in many departments, even outside of computing. So if you're doing research only, you won't be doing any development of any prototype or artifact that is separate from the research. This major development means that about 50% of the development is being graded at a high level with a lot of things expected, including technical specifications and much more functionality. Mini development is just a small build, and there's more focus on the research. But all of them includes research, including what we've done so far in this class. There's a chapter 1, introduction, like the concept note you did. So the concept note becomes a chapter 1. You know, it has all we did, the background, the problem statement, the purpose, the research questions, the significance, etc. Right? That's chapter 1. Chapter 2 is the literature review. I just got somebody sending me an email to say that they don't understand literature review. So maybe at the end of the class, I don't know if that's something people here are still struggling with conceptually. But it is what it is. So these are the options. And as I've said many times, we know that these are the 5 chapters that is standard in most research projects all the way up to a PhD. Usually a PhD, you usually have more than 5 chapters, but basically it would be that these break down into many chapters. So you might have many chapters for analysis and many chapters, like more than 1 chapter for literature review, but it's basically the same concept. So in SCIT, in BSc computing, these are the 5 chapters that you do for your project. The only thing we haven't talked about so far So just to let you know, what we're doing in the lab is helping prepare you for the analysis of results and findings. So what we're doing is we have been talking about introduction and literature review in the lecture. Where we are now is focusing on methods and procedures. And what you're doing in the lab class is helping to prepare for chapter 4. And by the end of this class, you should have some idea how to do conclusion recommendations. But we actually don't spend a lot of time on this. In a sense, you learn this by doing. Yes. And the other way you learn this is, by the way, if you go and look at any well-written paper, you'll see how they write up the conclusion recommendations. So you can learn this also from reading exemplary examples. Yes. So for the research and development projects, you're going to have an introduction and a literature review. In that literature review, you should also look at what has been software artifacts have been done, because you're reviewing not just literature on the concepts, you want to know what has been done in the past. So you have a thing. In the methods, you're going to include what software engineering methodology you're going to use if you're a BSc computing student, if you're doing a software engineering project. There's some possibility you might do some other kind of artifacts. If you're an animation student and this was a structure, you'll be talking about maybe the approach you're using. I'm not an animation expert, so I have nothing to say on that matter. And then for chapter 4, you analyze the data. Chapter 5, you come to some conclusions and recommendations. Remember, the conclusion is the answer to your one or more research questions that have been posed in chapter 1. There must be a strong connection between the research question in chapter 1 and chapter 5. And in fact, the whole thing should be linked. Just to remind everybody, if your research questions can be answered in literature review, something is wrong with your research question. You need to fix your research question. There is a relationship though between the research question and literature review. Usually it could be something like, let's say research question is contextual to Jamaica. Like, to what extent has academic performance been affected among computing students been affected? Let me see, what, you know, yeah, I don't know. I'm trying to say about academic performance. To what extent has students' experience been in the pandemic in Jamaica? There actually are a lot of people who are writing about, we could say it's tertiary students. There have been a lot of people writing about the experience of students during the pandemic in universities. This review is going to tell us all about what's been already written about it. But your project is about the experience of tertiary students in Jamaica during the pandemic. If anybody ever published that, you're going to put that too in your literature review. But something about your research question is not going to be answered in literature review, otherwise you need to fix the research question. Yes, and then the methods is now going to be telling you how you're going to actually answer that research question. I've been looking at as every single time. I see some people in my class giving me a draft of this, and their draft starts to tell them about the purpose of their paper. Literature review is not telling you about what you're going to do for your research question. It's only telling you what the literature says. And the last paragraph, you're going to be having something about, here is the gap in the literature, which you've already talked about in your study. And so because you've already talked about it in the body of the literature review, when you get to the end, you're just reminding us, well, we talked about these 5 things, or these 3 things, or these 2 things. And by the way, not by the way, here is the gap or gaps in the literature. And that gap or gaps, one of them or all of them should relate to the research question. So we have the introduction, the literature review, the methods, and obviously the analysis of the data you collected that you just talked about in the methods. So the whole thing is a coherent whole, and each chapter in itself is coherent, meaning you read a chapter by itself, it should make sense. But the whole thing together should make sense as a piece. So when you do a major project, you're doing all of this. For this class, you're only doing chapter 1 and 2, and you're going to do an ethics report for the methods. In the past, we used to actually ask you to write up the chapter 3. Now to make it easier on you, we're asking you to write the ethics application only, which is actually easier. And the reason why I also prefer it is because when you get to a major project, you won't be going, oh, what is this? Because you've already practiced it at least once. because we weren't doing that before. So we've now switched from asking you to write chapter 3 in this class. We're asking you to do the ethics application. So next week I'm going to be showing you example of how to do it if you haven't, if you've done it in your tutorial. So as I was saying earlier, there are different research designs in computing, and this is not a comprehensive list, but this is a list I have found. There might be others. So for information systems, which is, the other thing, just as a side note, do you know that computing is one of the newest academic disciplines in the world? For one, I'm not sure what the exact date is. The first working computer would have been around the late 1940s about. I don't know what date it is, guys. Let's call it 1949. I'm not sure it's the right date. So that's really what, 70 years or so that we've had computers, less than 75 years. And given that the academic discipline can be 75 years old. I mean, yes, I know Charles Babbage came up with the idea way before that, but we have a relatively new discipline. Most academic disciplines are hundreds of years old, if not thousands. So in that context, computing is still not only rapidly changing, it's even reinventing itself all the time. So in this context, we have information systems, which is the discipline that is how we can use computers effectively in organizations. And one of the research designs in information systems is design science. There is a lot of concerns about how computer systems, whether or not they're user friendly. And so there have been quite a number of research studies on usability. In computer science, there is the whole complicated methods, formal methods. I'm not a computer scientist. And then for software engineering, which some consider a discipline on its own, and that's a whole little controversy. Clearly, if you do introduction to software engineering, you know there's a very long list of methods that you can use for creating a software program. And I have a short list here. So types include prescriptive evolutionary team and other kinds of process models. So for no matter what you're doing, you would choose the appropriate design. And usually there's no formula as to what's the right design. What you tend to do when you're choosing a design for a project is that you want to look at what similar projects to yours have done before. That will help you with making good decisions. Obviously, you also usually have a supervisor once you're not somebody who already has a PhD and you're looking for your supervisor for advice. Okay, so I'm just going to go through some of these things in turn. So I mentioned that design science is one of the methods that is used in computing. So design science, I quite like it, even though I've really never used it formally. So this design science says that we need to think about building software sort of on the fly, where we're not only looking for requirements and field testing to make sure that the software that we build is relevant to the people. So to people, organizational technical systems. If you've ever done an introduction to IS, which in SCIT we call foundations of IS, you would have learned that if you want information systems to work, you not only want to make sure that it technically works, you also have to adapt it to the culture, as in that's the organizational systems, as well as to the people who work there. And so if you're going to make something, you need to think about people, organization, and technical. And so usually, as you would learn if you have done software engineering, you talk to real people to get the requirement specifications. And if you want to do it properly, you should test it, not just deliver it without testing. On the other hand, though, if you know about how people formally do science, they believe in testing using scientific theories. So is there any science out there in the scholarly literature that would help improve the likelihood that the software is of high quality? So there is the whole idea of grounding in the knowledge base. So let me give you an example of in an area that I have personal interest. So I have a lot of high interest in health apps and I have a master's in public health. And because I'm a master's in public health, I have decided that I want to be a researcher in what is called digital health or health informatics. What is interesting is that there are a lot of research about how people change behavior. So for example, if you have diabetes, diabetes type 2 is something that is linked to a lifestyle. So a lot of people with diabetes type 2 or other things, obesity, heart disease, a long list of non-communicable diseases is related to poor lifestyle. So maybe they need to do more physical activity, they may need to change their diet, they may need to find better ways to manage the stress, etc., etc. So in order to have better health, they should figure ways. So as you may or may not know, there are literally thousands of health apps. And when they look it up, most of those health apps have not been grounded in scientific theories, even though there is some existing theories that show how people change. So not surprisingly, a lot of the real health apps are not helping people. They're just there. So if you're like me and you want to be part of a team developing health apps and all of that, you want to not only look at it being relevant, you also want it to be rigorous because you actually want it to be relevant to the situation and for it to work. What is the point of you having something that doesn't work? Right? So relevance and rigor are both important. And this design science says, as we build something, we build it thinking about relevance and rigor. And this is a quick overview. You would now go and read about how you apply design science to a particular project. But it basically is you start and you look at both the rigor in the literature and what's on the ground, and you continue until eventually you get a artifact that is likely to be effective, and part of it is evaluating it. So next topic is human-computer interaction research. So because there are so many apps that the functionality is fine, but people don't like using it, or they like using it at first, but they don't continue to use it. You can think about organizations that have software that they require that people to use, but the people in those organizations object. In those contexts, usability is very important. If you're a business and you want people to pay for something, but they already stop because of the usability being bad, so usability for lots of reasons. Even if I say a health app, a lot of people stop using health apps because of usability issues. There's so many contexts where usability is really important. So the question is, how do you actually find out if software systems work well for people? There are different ways you can do the testing. You can ask people who are experts to review the software, and then usually there are expert checklists, and those experts look at that. So these are people who have higher levels of training in usability. In addition to that, you can actually do usability testing of the audience that will, or the end users that will use the software. So you can actually set up a lab where the people go in and use the software and you literally observe them. Typically with high-end companies, they even record it so they can look at it in the future. Or you can just actually ask people to use an app and you interact with them as they're using it. There are different approaches. So for expert reviews, there are heuristic evaluations where, for example, there's something called the 8 golden rules, and basically reviewers just go through those 8 golden rules and does a review and you record all of that. There are guidelines checklists where there's a set of things that the software should conform it based on what the organization requires, and the expert looks at that, looks to see if across the various screens, if it's consistent, basically have a list based on what requirements. Here are the most important tasks that are critical, as well as done frequently, and the expert goes through and does those things and sees how well it works and gives feedback. And there is formal usability inspection where there's a moderator who goes through and discusses the merits and weaknesses. So there are a long list of expert reviews that can be used. So as I was saying about usability testing, it tends to lead to better projects. So they're best conducted in usability labs, but that's really only feasible for medium to large size organizations that either own their own usability lab or can rent one. But for example, there's no reason why you can't do a project where one of your research questions is usability. You basically ask real users to come in person and you use it and you watch what they do. You could even do it in COVID because you just do it one person at a time and you end up have on mass. It's still possible. But the point is, these kind of projects you need. It's very time consuming to do good usability testing, right? So you can do it in terms of experiential study to see if there are two different groups. You know, for example, it could be that you have the software designed in two different ways and you look if there's a difference, or you can, because usually in practice you don't have time to do this in this way, as in with an experiment, you just create an interface, find out from the beta users if the interface works well, and if they give feedback to say changes, you change it based on that, and you just go through that quickly in order to, or you can do both. So you can do a combination of experimental and interface depending on the time and money you have for doing a project. And then in addition to that, you can do field testing where there's some trial period where you ask users to use the software, and lab testing. By the way, lab testing is considered more rigorous than field testing because you can control for so many things. You can control for gender, eyesight, level of distraction, temperature, time of day, etc., which in field testing, that's not going to be possible. So Lucid is a approach to design methods where you develop a product concept, perform the research and needs analysis, you design the concepts, including a prototype, and then you do iterative design based on the feedback, implement it, and always provide support. And if necessary, go back to the beginning if there is negative feedback. But if you do the iterative design properly, it's likely to work well. So other kind of studies that could help for user interfaces include acceptance tests, where you have, you look at what are the user subjective satisfaction, the time it takes them to learn specific features and functions in the software program, the time it takes them to perform each task, the rate of errors that they actually have when they use software, and how long do they retain what to do, Control S is way to save in Microsoft, whatever. If you have commands in your software, do people remember how to do it? And obviously you can evaluate during active use, where you have either interviews individually or focus group discussions. And there can clearly be surveys, which can either be online or printed surveys. So we said earlier that there are many different types of software engineering methodologies. So you know that probably the oldest software engineering methodology is the waterfall methodology, where you basically come up with the specifications. And when you finish that, that's when you do the next stage and the next stage. Waterfall is hardly used anymore these days. People tend to be using other kinds of evolutionary methodologies to develop. But whatever methodology you use, you should typically be justifying and using it as you have said in your methods. Okay, so that's all we have to say about that. Any questions on what I've shared so far? One people. All right, let me stop the share for a second. All right, let's go back to a second to, what is this? Don't know what this is. Okay. Why is this not downloaded? Open. Okay. Okay. All right. Hmm. All right, here. Okay, let me share screen again. So tell me, I do remember that at some point I had not finished this for one of my classes. I don't even know. So when we're doing something, which might have been either last week or 2 weeks ago, I don't know if anybody can tell me, but we had gone through that there are two types of sampling. There is probability sampling, simple, systematic, stratified cluster, and that there's non-probability sampling techniques, purposive, convenience, snowball sampling, and quarter. Did you go through all of them in this class, guys? Or is it you forget? I do remember that I did it different in each class, and in one class,
we went through the sampling techniques teach.
Okay, so since you went through the sampling techniques, let me just ask you, since I just asked this review for going further. Can anybody tell me? Let's just stay right on this thing. Can tell me what is quarter sampling? So we went through 8 different types of sampling. So we said, I'll just remind you first. So we said that all of these sampling techniques, probability sampling, is where they're all better than non-probability, because because you're able to have confidence in the data, because each of them have equal chance, the person have equal chance of being selected, right? Whereas the non-probability sampling, there's not equal chance of the people being selected. So purposive sampling is where you choose the audience based on some specific criteria, which makes sense. Convenience is basically the first come, first serve, that, and I reminded you that convenience sampling is not the same as random sampling. Random sampling is where you have a list, and that list is either used through picking through like a hat manually, or with a computer generated thing where you actually have every participant being equally. Convenience sampling is completely different. It's where whether you have a list or not, you're not choosing the people in a random fashion. It's just anybody who's available. Snowball sampling is usually where you have difficulty finding people, so you're asking anybody you find if they know anybody else. So I'm asking you, what is quarter sampling?
I don't remember it exactly, but I believe quarter sampling is when you're randomly selecting individuals who are supposed to be representative of your target you're looking for.
It's not random, because the quarter sampling is like stratified sampling. So stratified sampling is a random sampling of particular subgroups. So we had it here. So you have proportions. So you have proportions of, it could be you're proportional to men and women. It could be proportional, like, we had said that in engineering it's 80-20 split of students, and then you're of the numbers that you have in a list, you're doing it proportionally in a random way. The difference here, I know people tend to forget this, since I'm starting here. Quarter sampling is where you're doing it in a convenience sampling, but you're doing proportional to the subgroup. So you actually know the numbers that are in the groups, and then instead of using it randomly, you're doing it proportional to the numbers in the population. So like we know that in Jamaica, there is basically 50-50 of the population, 50 male and 50 female. So we could decide to do a survey in Jamaica and do a quota sampling of male versus female by we said we're going to go and do an online survey of 200 people and just make sure we have 200 males and 200 females. Or let's say we want to make sure quota based on level of education, and we're doing very simple, universities versus non-university, and I don't know what the percentages. Let's say 15% of the population have university education. We're going to make sure we have only 15% with university education. And the other not, sorry, I'm actually even saying that it's important because, you know, a lot of you students, when you do studies, they tend to have a lot of university students. It's not proportional to the population. So when you do generalizations, your generalizations tend to be more about people with university education than about the whole population. So that is why even when you're doing non-probability, quota sampling can be useful because it's more, even though it's non-probability, it's more likely to represent the population. Hopefully you're following me.
Yes, teach.
So we had said that there are some rules of thumb, so I'm going to go to, I think we were here. So there are two types of sampling errors, non-random, let me just go to slideshow from current slide, yes. So there are two types of sampling errors. There is non-random sampling error, and this is a flaw in sampling design. That is where you, let's back up. Sampling is the term for the choice of the researcher or the research team as to how to select from the population at large. Remember, the population of a research project is whatever is on the study. So if what's on the study is people who use TikTok, then it's all the people who use TikTok. If what's on the study is people who are sick with COVID, then the population is the number of people with COVID in Jamaica, right? So the study is, so the population is the number of people. The sample is the amount of a subset that you're going to be in the study. So in general, if you, like I just said, COVID, if at the end of it, if you want to study people who have had COVID, whether have it or had it, if it is that you don't make sure that the people in this study really had COVID, any result you come at the end, it's going to be problematic. So you need to find ways that when you collect data, the data is accurate. So if what you do is not accurate, you're going to have some conclusion at the end. So that's non-random sampling error. And there's so many ways in which you can get non-random sampling error. And then there is random sampling error. So the thing about this is, if you were to do an entire census, a census is when you get data from everybody in the population. Remember, the population is not of the country you're in, it's the specific focus of your research. Since the sample is not the entire population, there is a chance that even if you use random selection, as in the statistics, like, you know, let's go back here. Remember I just showed you. So even if you use these probability sampling techniques, which means that there's a high chance that the sample represents the population, it's not 100% certain. Why? Because even if the sample is large, it is still a possibility. Let's say the population is 10,000 and you do a survey of 200, maybe there's a 95% chance or a 98% chance that the sample represents the population, but it's not 100%. So because it's not 100%, here's what we're going to say no. We're going to say that a sample, it is only one of many possible samples. So any particular sample may not represent the population because it's a chance. So there's a way to estimate the random sampling error using statistics. So in general, It's on the screen. How does anybody reduce random sampling error? It's actually on the screen. You can't see. It's the second to last bullet point.
You have to increasing the sample size.
Right. Can anybody tell me why increasing the sample size is likely to reduce sampling error? Just logically.
A larger sample size means that there'll be more individuals in the study, so you'll have more people representing the population.
Exactly. It just follows this common sense, at least I think it's common sense. So the larger sample size, it's more likely that the sample is representative. Remember now, there's a still possibility of this thing called non-random sampling error. So for example, if it is that you're paying out people to say the wrong thing, you have what's called non-random sampling error. There's lots of things called bias. And once you have bias, you're going to have sampling error. But even if you use probability sampling and you have a small sample, then the random sampling error is going to go higher. So generally, you want to increase the sample size. And I think I'd said this maybe in the class. I don't know if I did or not. But see here, there's actually a study that said that the sample size beyond 400 is normally considered the largest you should do. However, that doesn't mean that you should do a sample size of 400 enough. There are these statistical calculators that you can use to actually calculate the a number that is best for your population. What is normally done, apart from the rule of thumb, is that in excellent research, you figure out the type of statistical technique you will use, like a t-test, like a multiple regression, like correlation, etc. And based on that and the population size, you put in the type of statistical test you will use, the size of the population, and a number of other factors. You put it in a statistical software, and it gives you the size of your sample. But just generally, rule of thumb is that your sample size should usually not go beyond 400. So I'll give you other rules of thumb is that remember, I said it earlier, 100 is usually the minimum for a survey. For qualitative, usually the minimum is 30. I mean, there are exceptions though. And usually for experimental, it's 15 per group, which that basically usually is 30 or more. So, right, and then we also give you another rule of thumb. You generally don't want to be on 400 because it's basically a waste of time and money, because you're not going to reduce the sampling error because there still could be some, but it's still never going to be perfect. So the thing about it, the sampling bias affects your ability to generalize. So generally speaking, you want to be able to come up with a study that you can actually generalize on. All right, so we already know this, that there are different types of empirical data, and a study that uses both quantitative and qualitative actually have two terms. There's actually mixed methods and multiple methods. Technically, a multiple method study is one where the quantitative doesn't affect the qualitative and vice versa. And technically, mixed methods mean that it's what most at the undergraduate level, most people just use mixed methods, whether it's multiple or mixed methods. So let's not worry about that too much right now. So we know by now that we have focused on experimental survey research, correlational research, and there are a number of types of qualitative research, which we have not spent a lot of time on, but it can be done. So, time we have less. Yes, all right, so we're basically almost out of time. So this is just taking 2 seconds. So we know that in statistics, we have descriptive and inferential statistics. There are 4 types of measurements. Nominal measurements are ones that it's just whether it's the order doesn't count. So like male, female, or faculty at UTech, there's no order. Ordinal means that there's an order. So for example, here's working class, middle class, upper class. You know, I can't think of another one right now. Interval, where there are some real numbers that are in order. So for example, age level would be a interval score, or like grades, like ABC is also an interval as well. That's an interval. And then ratio is where there's a real number, like your actual age, 1, 2, 3, 4, 5. So these are the 4 types of measurements when you're using numbers. And when you're using a statistical program, you actually normally have to define which one that you're using. So in descriptive statistics, remember there are 2 types of statistics, descriptive and inferential. Just a reminder, everyone in BSc computing, we're expecting you to not only do descriptive, also the inferential statistics. So descriptive statistics is things like talking about 1 or 2 variables, and you should be able to create tables. You should be able to create bar charts and pie graphs. You should be able to talk about them. You should know what mode, median, and mean are. I'm not going to talk about this, is all on the slide. You should have learned this all in high school, so this should not be you should be able to draw graphs and talk about whether they're positively or negatively skewed. You should be able, because this is all high school stuff, you should be able to, the one thing that's not high school is standard deviation. You should be able to talk about the variability of the measures. Now, it depends on which project you're doing as to how important these things are, but they can really help by talking about these variables. They can really help describe the data. So they're all described on the screen. And so this is showing you like the variance that shows you how these dogs vary from the average. And this shows you the actual calculation. The truth is, since statistical software does all of this, you don't need to do it yourself. And the standard deviation is just the square root of the variance that we showed earlier. And standard deviation basically tells you how close the other numbers are to the mean. So this shows you the actual formula and example of how to do it manually, which you don't really want to know right now. But you can do all this in software. Univariate analysis is where you have one particular variable and you're just looking at the trends in that variable. So typically, almost everything in the world that you collect tends to follow the bell curve. And if it follows the bell curve, within 3 standard deviation from the average, there is most of the data, 99.8%. Yeah. So that's it for today. Any questions?